Action.
Hello everybody, my name is Professor Suborno at Bari, and today we are looking at, it's live. Today we're going to be looking at torque. So, for the do now, this is going to be an introduction to torque. So, we're going to learn something new. Well, we always learn something new, but still. So, this is tau, the symbol for torque, first of all. Now, let's say we have
What did you draw, Professor?
Thank you,
a door.
Prof.
A door?
This is a door from a bird's eye
Can
view.
you write big, please?
Yeah, this is big.
This is big door.
Thank you.
So this is the hinge. You always see that. You can take an example from the classroom over there.
Thank you.
So this is the hinge. And this is going to be the knob. So, no, there's going to be no knob for our example. So, let's say that there's F1. Let's say F1 is acting,
Why F1 is not at the end of the door?
No, I'm going to make I'm going to make certain F's. Okay, let's say F1 is R1 equal 20, no, that's too long of a door. 12 meters, I guess. That's still quite a long door, but you can't argue. Now, this, let's say there's F2 here, and then F3 is a third, so about here. So, sorry, Towson, we have to erase you. So let's say R2 is only half, and R3 is only a third of R1. So, 4 meters.
What do you want us to do?
Wait, actually, this is too long of a door. 6, 3, 2. Yeah, that's a big one.
What do you want us to do, Professor?
So, I want you to find, I want you to find the magnitude of F1, F2, and F3, just your hypothesis for the magnitude of F1, F2, and F3 based on the distances. I'm going to give you a hint. For them to have exactly the same torque. I'm going to give you a hint. Torque, how do I write torque? I'm not sure. Torque is directly proportional to distance. So I'm going to give you that.
Is it?
Yes.
So, Professor,
What does that mean?
F1 is, can we say F1 is 1 Newton?
F1, I don't know. I'm going to give the distances.
You already gave us the distance. Can I say F1 is 1 Newton?
Okay.
Please.
F2 is 2 Newton?
F2, 2.
F3 is 3 Newton.
Okay, you guessed correctly.
I think F3 is 4 Newton.
No. Look,
Oh.
R1 is, R3 is exactly a third of R1. In order for F3 to be 4 newtons, it had to be 1/4 of R1.
Oh.
Thank
So,
you, Prof.
in fact, even though F3, F2, and F2 are much bigger than F1, these are all exerting the same torque.
So-
Same if you, same for,
Wait, that doesn't make sense. So even if you increase the force, the torque is the same?
yes,
Makes no sense.
it also depends on the distance of, the force relative to the axis of rotation.
Oh, but
That's right.
In this case, the hinge.
That's right. Okay, Professor.
This man does not know how a lever works.
Professor, can you show the proof of torque formula F is equal to, T is equal to F L sin theta? Please.
Oh, how do you know? You saw that in your homework last night. weren't you?
In the textbook, I don't understand it.
Oh, you don't understand. Sorry, I know all these textbooks are garbage. You should have bought the Giancoli one.
Yeah, and I watched the Khan Academy video. I still don't understand.
Yeah, Khan Academy not that good. So T equals
Wait,
FL sine
okay,
theta.
Professor.
He's asking me to post this. Well,
Prove
how do
that.
we start that? So we're going to start from an easy example. So let's say the door is just here. This is R and this is L. Now, this is going to be F.
Oh, okay, Professor. Yeah. I
This is
kind
going
of
to be
understand.
F. And
What you're trying
this
to
is
say.
going to be F. And you can see that it forms a right angle over here. So you can see that the force vector and the R vector or the L vector
But Professor,
are perpendicular.
what is the proof? What are we trying to prove?
FL sine theta. And using SOHCAHTOA, which we'll do later when we look at a more complicated perspective, we can get FL sine theta. But it doesn't really matter, the sine theta, because sine 90 is just 1. So that will
Oh.
just give you FL
So
or
what is
FR, because those vectors have the same magnitude in this
Professor,
case.
Oh, you
Why?
keep forgetting the tau.
Wait.
Oh yeah,
Why?
tau.
Why you read L? Is it R and L the same thing?
What is the equal
Yeah,
sign?
they're
Why is
interchangeable
this?
for
Just
now.
Why you keep writing L and R? Just use one symbol.
Yeah, they're
Why?
interchangeable for now. They won't be interchangeable later on.
Mm. So,
We'll see that
so
later
L and R always not same.
Not always the same.
Okay.
Can you
So-
show an example where L and R are not same?
Yeah, we have almost 150 students, by the way.
Wow.
This class is getting pretty popular.
Thank you, Professor.
God, you don't have to say thank you to every. I like the gratitude, but God, you don't have to be over gratitude. What is the word for that? Okay,
He just doesn't want to fail the class. So he suck up the professor.
suck off the sympathy, trying to evoke pity. Sympathy, pity. So, L and R. And then, let's say the force vector is at some angle where if it reaches...
I don't see the
only-
angle. Can you make the angle a little bit more? What kind of angle is that?
Yeah, that doesn't really match up the way I
Can't
want
see
it.
anything.
Jesus
Professor.
God.
Let's try better next time.
Yeah, this looks good. You can, if you can't see the angle here, you're probably blind. So, no offense, but okay. So,
Let's keep it simple.
if with this force vector extending on and on, it would be perpendicular to R. That's the information I'm giving you. And it's at a direction in angle theta respective to the y-axis. So now, how can we find it in such a dilemma? Well, if you look closely, you may see a right
Professor,
triangle.
I think the other one is the angle because the vertical angle are same.
Oh wait, yeah.
I agree, yeah.
True. It's kind of hard to see, but
You need
due to some geometry, these are congruent.
No, not this.
Oh yeah.
No, that one. Professor, that one. Draw all the angles in the
Mr.
triangle.
Rodriguez. I
Yeah.
am not sure which one you're pointing to.
This one. This angle, Professor. This angle.
Ah,
Oh,
this
these
one.
two are congruent.
Ah, yes. Oh, ah. Gosh, I'm saying I'm oh so much. So it's very confusing. I may need a different color to highlight this, but you may or may not see a right triangle formed by the R and L vectors.
Really, Professor?
Yeah, saying that R and L are not congruent in this example.
Thank you, Prof.
Oof. Okay. Now, I'm going to look at this in further detail by rotating it. So when I rotate it, we get L here and R over here. Wait. R? Wait. I think R should be, no. When you rotate this, R should be.
So sine is
But R should be here when you rotate.
sine is opposite over hypotenuse.
Meaning where theta is here. Oh, okay.
Acha.
So here we know the hypotenuse.
No, professor, the theta is on the top.
Oh, when you rotate this from my perspective, it seems that the theta goes here.
Professor, what are you trying to prove?
The theta, okay, we're trying to prove FL sine theta. Don't you know? What?
So, why don't you just...
Yeah, no, look, this theta is next to this right angle. It should be the same over here. So we know the opposite, it's R, and we know the hypotenuse, it's L.
Oh, Professor.
So what we can use is SO, CA, TOA. Well, we definitely don't know the adjacent, so that answers the question. Crossing both of these out,
Okay.
meaning the only choice left is sine
we have
theta.
to express R in terms of L and theta.
Yeah, so you can see opposite clearly is R, and hypotenuse is L. Meaning that if you do cross multiplication, R is L sine theta.
But professor, that's not what I want. I want the f at tau equal to.
Yes.
Tau equal to.
We're just one step further. FR, so that's going to be equal to FL.
Oh, we have to substitute in for R.
God.
Thank you, everybody.
Salute, salute, professor, salute.